Hello and welcome everyone. So in this video we're going to step away from C++ for a while and start testing our blueprint system for the gameplay ability system, and we're going to do some basic preparation to use our gameplay ability system, and we're going to go over specifically the melee ability in this video. So let's start off by creating a new folder and just call this BP base classes. Okay. Once this is created, go back to your C++ classes, gas tutorial, public, base character, and then right click on this and select create blueprint class based on base character, and select the folder BP base classes and rename this to BP base character. Create a class. Now you see this is empty without the mesh or the camera and that kind of stuff. So just to save time, what we're going to actually do is go back to our third person character and copy it over here. Copy this and just delete this. We don't need this anymore. And just rename this one to BP underscore base character. And you should see, just make sure that the parent class is our base character that we created inside of C++. And next what we're going to do is that I'm actually using Paragon Greystone as our player character. So what I'm going to do is copy its blueprint to our base character class, and I'm going to rename this to BP underscore player character. Okay, and the first thing that you want to do is actually go to your class setting and change the parent class to BP underscore base character. Now remember, this is the BP variant of this and not the C++ one. And we're going to delete these because these controls are already present inside of the base character, and we're going to leave this melee system because we're going to be using this melee system for our example. For your own project, you might want to move this melee system to your base character so that your player as well as the enemy can share this same combo system throughout your game. This is just one way of doing this. You need not follow this, and you can use your own blueprint programming knowledge in this, but this is one way of doing this. And I will spell this wrong, CHA. Okay, and next what we're going to do is also duplicate this and rename this to enemy character. So the way our hierarchy is now set up is base character is the parent of the enemy character and the player character as well. And just to differentiate between our base character and the enemy character, what we're going to do is change our meshes. For the player character, what I'm going to do is select our paragon, this one, delete this, we don't need this, compile and save. For the enemy character, I'm going to leave this as the default and delete this and delete this. Next we want to do is create some initialization for our attributes for health, mana, and stamina. The way you do this is go to your base character. We are doing this in base character so that our player as well as the enemy have same starting attributes. You may want to do this differently for the player or the character, but the procedure for this will remain same. For the base character, go select your ability system component, and here you should see attribute test. And click on the plus icon, open this up. For the attributes, select the base attribute set, and for default starting table, what you're going to do is actually create a new data table and select our folder and just rename this to initial data table. For the row structure, select attribute metadata, click OK, double click this. This is going to open up, and so here what we're going to do is actually initialize our attributes. Click on add, and first one is going to be base attribute set dot health. Now the way this works is first you define your class name and then the attribute name, and for the base value what we're going to do is actually set this to 190. Min value and max value is going to be 200. Don't worry too much about these min and max values. The clamping is already done inside of our C++, and we're going to set the same for our max health, and max health is going to be 200. Duplicate this, and this is going to be mana, and mana is going to be like 80, let's say. out of 100, and we're going to duplicate this and rename this to max mana, as it's going to be 100. Duplicate this, and I'm going to set this for stamina. Stamina is going to be like let's do 90 of 150. Duplicate this, and this is going to be our max stamina, and this is going to be 150. Save, and now we're going to, this is already set inside of initial data table. Compile and save this. And just to visualize this, we're going to actually create a user interface so that we can visualize our health, mana, and stamina. Go back to your content browser and select user interface, widget blueprint, into UMG, player interface, no, player UI. Better name. Could have used a better name, but okay. Drag out a progress bar and just rename this to health bar. And we're going to change the anchor to center, zero this out. This is 300 by 30. Alignment is going to be minus 0.25, and this should be 11, I think, and anchor should be over here actually. This out again. For the color, I'm going to select a red for health. Okay. Now I'm going to duplicate this and rename this to mana bar, and this is going to be of the color blue. Okay, and we're going to set the same one for this, and this is going to be 9. Duplicate again and then rename this to stamina bar, and change the color to green for stamina, because stamina is always green. And change this to 7. Okay, so once this is done, we're going to actually check for attributes from our player character and then call these to set these values for the percentages. First of all, move on to graph and create a new variable called umg underscore owner. And this is going to type bp underscore base character object reference. I'm going to say this again, that my programming practices are not the best in the world, and you can go with your so-called good programming practices, but for the tutorial's sake, I'm going to just keep it simple and, well, dirty. So just what you can do is actually set this value inside of our base character, and back to our designer. What we're going to see is actually set the binding for these percentages. So create binding and call this umg owner. Now, since this is BB base character, it should have the function get health values, and drag this out and then divide these two values to get our percentage for these. Similarly, we're going to do one for mana with binding and drag this out, get mana values, drag this out, and going to be over here. Okay, similarly for stamina, bind, we're going to stretch it out, get stamina values, and divide these two values. Okay, oops. Now this is done, and what we're going to do is inside of our player character actually, because we don't want the enemy to have this user interface. So on begin play, what we can do is call our parent, and a call to parent function, and then what we can do is say create widget, and we're going to select this class umg player UI, and from this we're going to say and promote to this to a variable. Sorry, we might need this in the future, so you can do umg interface player interface. Okay, and from here we're going to say set umg owner, and since player character inherits from our base character, so a reference to self should be valid. And after this, what we're going to do is actually add to viewport. Okay, this is done. So if we drop this character inside of our blueprints, we should technically see our interface. Oops, our interface is there, but okay, this. We set it to possess the by player 0. Yep. And you'll see one thing, that our combo system is not working. This is because of the freaking casting system. So what you can do is actually move on to our Paragon Greystone folder, characters, heroes, Greystone, and Greystone, and in Blueprint. Now this is the reason casting is so bad. You should use interface calls. Okay, if we're going to cast to dp underscore player character, and this is going to be this one, and we're going to call combo attack save. I'm going to copy this, paste it over here, and this is going to be reset combo. This should fix this problem, hopefully. Okay, so our combo system is now fixed. Let's try changing the value of health, mana, and stamina to something else. So see, difference is this is going to be 200, and stamina, let's do this like 10 for the time being. And the changes should have been reflected over here. Yes, they are there. But let's move the stamina back up to like 140 at least, just to keep it more visually understandable or appealing or something like that. Okay, so our player character is done, and we should, while we at it, we should create a user interface for our enemy character as well, so that we know their health. So it's going to be umg enemy health, and same thing. What we're going to do is drag out a progress bar, set the anchor to center, zero these out, and 30 by 300 by 30. Alignment is going to be 0.5 by 0.5. And for the color, I'm going to go with red again. Yes. And for the screen, is going to be desired. And I'm going to create a binding for, first of all, I have to create the variables. It's going to be umg owner. This is also going to be dp underscore character, sorry, base character, object reference. Okay, and for the binding, I'm going to drag this out and call it get health values. And this is going to be our health percentage for this. Compile and save this. And now let's add this to our enemy character. Select your mesh and call widget and rename this health bar, and change this widget to our umg enemy health, and change the space to screen space. Drag this up, compile and save this. And also over here, we're going to call begin play and call to parent function, and then just drag this out of here and say get widget, and we're going to cast this to enemy health, I believe, yes. And we're going to say set umg owner, and this is going to be self. Okay, so if we drag our enemy over here and change the health to something less than 200, like 150, let's say. So what we should see is, let's set the rotation first. You should see over here, and this one should see over here. Let's play this, and our enemy has now a health bar over here, and the melee function is still not working. Okay, that's our next task. So now we are going to actually move to implementing our gameplay ability for this one. And the way this works is, I'm going to just simply create the ability, and we're going to do an explanation in a later video. But let's just follow along for now and go and create a blueprint class. And this is going to be the type game gameplay ability. And it's going to be this one. I'll name this GA underscore melee. Open this up. So whenever an ability is activated by the ability system component, this event is fired. Just to test things, we're going to just do is a print string and say ability is activated. And once we are done with this, we're going to actually call end ability. So you need to have an end ability because we don't need multiple instances of this ability. Rather, we want just one instance to be fired and then closed. Compile and save this, and let's close a few of these. We don't need these so many over there. Okay, and moving back to our player character, what we're going to actually do is first actually grant the ability to our ability system component to tell this, hey, this is an ability available to you, and then activate it on the left mouse button. So just after this begin play chain, what we're going to do is call our C++ function initialize ability. And for the ability class, we're going to say GMLE, and this is going to be this one. Sorry. Okay. And to activate this, we're going to break this connection and call the function try activate ability by class. And this is going to be same GMLE. Drag this over here. And what you should see is instead of the combo system, we are printing ability is activated. So our ability is now firing. Now let's actually change this ability to do the animation for us, because after all, that's what this ability is supposed to do. So we're going to delete this. Okay, let's not delete this. Cut. Relink this back over here and right click on this, promote to variable, and then keep the name as Anim montage. And we're going to delete all of these. These are going to actually played by our ability, GMLE. And after this, going to say set Anim montage. And it is going to be primary attack A, duplicate. This is going to be primary attack B, duplicate this, and this is going to be primary attack C. Okay. And after all of these, we're going to call the same function. Oops. It's going to be try activate ability by class. GMLE should be selected. Okay. Drag this out over here and make this GMLE. So once this is done, move back to GMLE. On the activate ability, what we want to do is call the function play montage and wait. Okay. And for the montage, we're going to say get owing actor from actor info. And we're going to actually cast this to bp underscore player character. Now remember, these Anim montage variable was present on the player character and not on the base character. You get the idea how to make this like good programming practice. And when you get Anim montage and also get melee speed, and plug this over here, and we're going to do nothing on this node because we don't want anything to be done when we're playing the animation, but once we are completed or blend it out or interrupt it or cancel, we want to end the ability. And also, if our cast fails, we're going to end the ability immediately. We don't want an instance to be lying around over there. Okay, so hopefully our ability system should play the animations. Okay, our combo system is working. So our ability system is doing something. But we haven't implemented a damage function. So moving on to the damage function, first of all, what we're going to do is actually tell our melee ability that while you're playing the animation, you're going to listen for something. And that something is going to be a gameplay event. So drag out here, wait gameplay event. And it is asking for a tag. Now, we're going to go over tags in the next video, but for now, understand these are ways to identify all of the things inside of this whole gameplay system ecosystem. Like this class has a tag system over here. So for this tag, we're going to add a new gameplay tag and call this character for char for character, and ability dot melee dot hit event. Add a new tag. Now, where these tags work is that it creates a hierarchy after each dot. So whenever this event is fired, it's going to listen for this event, and once this event is fired, we want to say apply gameplay event to target, and target is going to be from our payload, and we're going to break this and get our target, and we're going to convert this to ability target data from actor, collapse this, and plug this into target data. Then it's asking for a gameplay effect class. Now this is the thing, like I said in previous video. I think so I said it in previous video. If not, well, live with it. So gameplay effect is the thing that actually acts upon the attribute system itself, and it modifies the attributes directly. So we're going to create a gameplay effect class, go back to our content browser and right click, like blueprint class, and create a type gameplay effect. And this is going to be this one. Call this GE underscore melee damage. Okay, open this up. Now remember, this is a data only blueprint. You don't need to do anything inside of the graph, rather inside of this class defaults. And for the duration policy, we're going to be instant, because damage has to be applied instantly, and it's not going to be infinite, or it does not have a duration. And we're going to add a modifier, and we're going to modify our health attribute and the magnitude, and the operation that we want to do is add. There is no subtract, but don't worry, what we can do is add like -10 to the health. Adding -10 is basic subtracting. Simple math. Simple, basic, something. Okay, so once this is done, this class is created. Go back to our GML class and plug this in, GML damage. And this, we are listening for this event over here. So we want this event to be sent to this character on the overlap of this sword. So what we're going to do is select the mesh and create a capsule collision, and call this weapon. Okay, and we're going to attach this to sword bottom, and approximately size this to our sword. It doesn't need to be exact. And you can use your other systems like the trace system or the hitbox system for the melee, but for this tutorial we're going to stick with this collision system. Okay, so this is done, and inside of our event graph, what we're going to do is create an event for one component begin overlap. So when something overlaps it, now just to add some sort of faction system, like to identify between our player character and the enemy character, I'm going to actually cast to BP underscore enemy character. You can use your faction system or like testing system over here, that what object can be damaged and what cannot be. And if this is valid, what we can do is send gameplay event to actor. And for actor is going to be ourselves, because we are listening for the event. And for the event tag, what we're going to do is call this same character ability melee hit event. And for the payload, what we're going to do is actually set our target to this character. Okay. And now, if we play this, so now if we hit play, what we should see is that our character damages our enemy. Okay, it's decreasing our health. Now the collision system is not perfect right now. You can see it's hitting twice, but you get the idea. Okay, next we want to do is actually consume some stamina when our enemy is, when our player is actually performing this ability. So if you move back to GML class, you'll see over here cost class. It's also a gameplay effect class, and what you're going to do is create a new blueprint class of the type gameplay effect, and we're going to call this GE underscore melee cost, and this is going to modify our stamina is going to be stamina. We're going to decrease this by, let's say, 15 for each ability, each ability execution. And we're going to set this as our cost class. Now, those of you who are familiar with this system, you'll see that I'm not using these tags for now. I just want to keep this simple. We're going to cover these tags in the next video or in some future video or somewhere in the future. But for now, just roll with this. Okay, so let's try and simulate this, and you'll see that we are not costing any stamina. This is because we have not committed our ability to use cost or the cooldown as well. So moving back to GMAD, whenever we activate this ability, what we want to do is call the function called commit ability. Now there are separate functions for cooldown and cost. If you want them to use separately, we will just call this commit ability, which is going to commit our cost and cooldown at the same time. Now hopefully this will work. Yep. And this is costing us stamina, and you'll see that once we run out of stamina, we won't be able to perform our ability. Now there is approximately 5 stamina, I think, but it's insufficient because the cost is 15, so we cannot perform our melee effect. The ability is blocked. Okay, so this is it for our melee ability, and just to give you an assignment, yep, assignments are necessary. I've created this GE fire thing that when I move over this, it's costing me like 5 damage. Oh, this is too much damage. It's costing me some damage over time. Okay, so this is your assignment. Just to give you a hint how this works is, you should not cheat, but just see this once you're done. You see that I'm getting the ability system component for this and checking if this is valid, and then applying a gameplay effect to the ability system component that's overlapping this box. Now, gameplay effect should be applied to ability system component, and they do not need some actor. They act directly upon the ability system component and the attribute set. So try implementing some of these functions on your own and see how this works. So this is it for this video, and thank you very much. In the next video, what we're going to do is move to the explanation of what we have done so far and just get an overview about the gameplay system inside of Blueprint itself. So thank you very much.